So the flow goes on. Just how the applications were basically on security and cybersecurity, but we are going to end up with García-Rasines, and he's going to show us some applications starting on business competition in a project with Garcia.
First of all, I'm Daniel. This is I'm going to be presenting joint work with Roy, Simon, and Cesar. And I'm going to be presenting some applications of adversarial analysis to financial application, and I will be focusing mostly on lending problems. So typically, the decision problems that businesses face are characterized by three characteristics. So first of all, they are competitive in the sense that there are other businesses in the same market sector which are making decisions at the same time as us, and they are competing for our market share, or maybe there are some attackers which would benefit from attacking our company for some reason. Second, there are decisions that need to be made under uncertainty conditions. So, for example, regarding the volume of clients that we will have in the future, and also regarding the adversaries that we are facing. And finally, sometimes these decisions need to be taken we have to take several decisions at different time points. So they are dynamic problems. Most of these problems have been tackled already using concepts in game theory, but usually these solutions make very strong assumptions, especially regarding the knowledge that the supported agent, that all the agents share. And so instead, we will try to solve them using adversarial risk analysis, which provides a more simple, more principled way of modeling this kind of situations. So this is a list of possible applications of adversarial risk analysis in the business sector, and in particular in the finance sector. So first of all, we can consider two different types of situations. One where the other agents making decisions at the same time as us are competitors. So, for example, we might consider a bank or an insurance company which is competing against other banks or insurance companies to attract a lot of people that are looking for a retirement plan. We might also consider competition for attracting borrowers. So we would have competition in the loan market, and we would also have competition, for example, if we're trying to model the stock market and we wanna forecast what other businesses, what the stocks other businesses will buy in order to optimize our decisions. And the second kind of problems that we can deal with this framework are problems where the other agents making decisions are attackers, and they somehow benefit from attacking our company. So, for example, we might consider fraud detection problems where there is some individual or some business which is trying to make a fraudulent transaction. So in that case, he would be the attacker, and we can try to model that. Or we may have a situation where there is someone inside our business who would benefit from, for example, changing our market value and making us make decisions which are not optimal. So I'll just give a brief overview of how some of these problems can be tackled, or what kind of characteristics they have. So in the case of the retirement plan market, we would be able to consider two different types of problems. A static problem in which we have some person which is interested in getting a retirement plan, And we want to make them the best possible offer so that our earnings are maximized, but taking into account that that person is also going to asking other banks or insurance companies for a retirement plan. And we could also consider a dynamic problem where we want to strategize our decision making for the next K time period. So for example, we want to commercialize some retirement plans and we want to decide in advance which ones are the best. And to do that, our decision space could include these actions such as marketing investment, give bonuses to customers to attract them, give them presents, modify our products, etc. Now, another problem that can be dealt with this framework is about modeling the stock market. So suppose we want to make an agent learn how to trade in the stock market autonomously. So typically, state-of-the-art models will do this by using reinforcement learning algorithms. The problem with them is that they usually assume that all the agents buying and selling stocks are independent. So adversarial risk analysis allows us to model these interdependencies and therefore gives us a more principled way of solving this problem. And now the problem that we will be considering more closely is that of competition between banks or lending companies in the loan market. So first of all, obviously loan pricing is the main source of income of banks, so and therefore is a problem of primary interest to them. Typically in the literature, this problem is tackled using game theory models. However, these models have a lot of problems. So first of all, they tend to focus only on the static case. Second of all, they tend to make very strong assumptions about the borrower and the competition to be able to find the solutions analytically. And second, they are very difficult to expand to more complex scenarios. So for example, to include variables such as guarantees, etc., that the bank may want to add to the offered products. So we will be considering a static and a dynamic version of this problem. In the static version, we will consider a potential borrower which needs some money to carry out a project. Now the project is characterized first of all by the amount of money that is needed to invest on it, which we know by X. Second, depending on random elements and things like the state of the economy, we assume that each project might either fail or be successful. If it fails, we assume the money it will return is zero, and if it is successful, then we will model it by some distribution. And because in order to solve this problem, we will need to consider the borrower's decision making. We will assume that the supported bank has a requirement for the borrowers that apply to that bank, which is that they have to present a business plan, and in particular, they have to justify an estimate of the return they expect with the product. Okay, so the first decision the banks have to make when receiving a lending application is to decide how much screening effort they're going to make. So screening basically, so they can screen first of all the borrower by contacting credit agencies and find out what's his historical credit behavior. So for example, if they've been granted a lot of loans but they weren't able to repay most of them. And second, they could request an evaluation of the project to see if it's viable or not. And obviously this has an application code C, which will be worth making if as a result we get high quality information about the problem, about the project, but otherwise it will not be worth. And we assume that after the banks have decided on their screening expenditure and they have obtained information about the borrower and the project, they will have a distribution over the return of the project, which is given first by the probability that they give to the event that the project will be successful or not, and then given that it is successful, they will have distribution for the return of that project. Now, once they've screened the project, they will have to decide what, first of all, whether they will make an offer to the borrower or not. Second of all, if they do make an offer, then they will have to decide which interest rate to propose to the borrower, defined over the lent money, so over X. Now, because extending a loan always costs some money to the bank because they have to pay the people to do that, we will assume that the interest rate is bounded from below by some constant, because otherwise the bank would always lose money. And third of all, they would have to decide the penalty that the borrower would suffer if he wasn't able to repay the loan. So we will assume, for simplicity, that this penalty involves a seizure of the borrower's belongings with some economic value that is given by a function of the amount of money that is given to him, the interest rate proposed, and the final return of the project. We're going to assume that the return of the project is publicly verifiable, so there are no issues with the client lying about the result, etc. And then once the project is finished, it will produce some return gamma, and the borrower will have to repay the bank either the amount we had asked for, which is 1 plus alpha times X, or the return that the project had in case it is smaller than the required amount. Now, what are we trying to maximize when deciding an offer? So we assume we are going to maximize expected utility, of the money we make from that offer, which is given by, first of all, if we don't make an offer, or if we make an offer and the borrower doesn't accept it and it goes to other bank, then we just lose the money we spent on the screening and we make nothing from the project. In other words, we will get some money, which will depend on how the project turns out. Now, in order to solve this problem, we need several ingredients. So, first of all, we need to have some sort of idea of what the project return will be. This is typically done by screening, as we mentioned before. Second, we have to have an idea of the client's of the problem from the client's point of view. And for this, and this is the reason we ask them to bring a business plan so that we get an idea of what they think of their own project. We will also need to assess the distribution of the conditions offered by the competitors. So this could either be done either by using past data or by applying some standard methods in adversarial risk analysis based on considering their decision problem. And finally, we'll have to assess the probability that if we make an offer, the probability that the borrower will accept that offer and not go for our competition. So in order to solve this problem, we need to consider the borrower's decision problems as well. So we assume that the borrower is maximizing expected utility with some utility function E of B, which we typically don't know. Now, if the earnings are given by the return minus the money it has to repay to the bank minus the penalty if the project ends up failing. Now, because we don't know this is utility function, we will assume a random utility function. This will in turn generate a random utility psi of JB, and then we will estimate the probability that the borrower accepts our offer by checking how many times that psi of 1b, which is his expected utility from accepting our offer, is greater than either 0 or the offers of the competitors. Now, to give a practical example of how this might work, so suppose someone brings a project and asks for 10,000 euros to carry it out. Suppose he justifies an estimate of the project returns in case it is successful of 20,000 euros, and suppose our cost for getting information about the project is 200 euros, and that the interest rate that we can offer is has to be at least of not 1. Now we will assume that that the bank we are supporting has a constant absolute risk aversion utility function with risk aversion coefficient equal to 0.5. Because we don't know the utility of the borrower, we will assume it is also a constant absolute risk aversion utility, and then we will model the risk aversion coefficient by an informative prior, which is uniform between 0 and 1. Now, for the penalty, we'll assume that if the project fails or if it is successful, but the return doesn't cover all the repayment that needs to be done, then we will assume that the penalty of the borrower is a seizure of his belongings with the remaining with an economical value equal to the remaining payment. Now we assume that as a result of the screening that the bank has done of the application, we conclude, or it concludes, that the probability that the project will be successful is 0.95. And then we will assume some assume some prior distribution over the return in case of success. We will also assume that other banks make an offer, which is going to be between 0.1 and 0.1. And because we don't know its value, we model it with a prior distribution which is uniform on that interval. Now, in order to assess what the borrower thinks about the project he proposes, first of all, we're going to assume that his beliefs about the return of the project, if it is successful, are modeled through a normal distribution with the mean that he estimates and some non-informative distribution from for the variance. Now, because the borrower is applying for a loan, then of course he would always accept a loan with null interest rate. So in particular, this would imply some sort of bound for his some lower bound for his estimated probability that the project will be successful. Because if his estimated probability was below that, then he wouldn't be applying for a loan. So that gives us a support for his estimated probability, and then we will assume a uniform prior distribution of that support because we don't know what it is. Now, some results. So if we apply that this case with only one other competitor, 3 competitors, 2 competitors or 3 competitors, then we basically what we observe here is that as we expect, the optimal decision is to propose a lower interest rate as the number of competitors increases. Now we will consider a dynamic version of this problem. So suppose, so instead of a borrower coming to us with a project and we devising a proposed and we deciding on what interest rate to propose to him. Suppose we want to devise some lending strategy where we propose an interest rate, and then we let borrowers come and apply to us and decide whether we accept or not. And so our goal will be to, so we assume we want to make decisions for the next, for example, K time periods, and we want to decide for each time period which interest rate we want to offer. And to model this, we need to add 2 more variables to the model. First of all, we have to consider the state of the economy, which will give us an idea of the volume of applications we will receive and the quality of those applications. And second, we have to consider marketing effort to be able to make our products known to the potential borrowers. So as before, the products, the loans are defined by the interest rate that we ask the borrower, the defaulting penalty if he isn't able to repay it, and now we have to give a range of possible money that the borrower can ask for, which we need to decide. In addition to this, we again need to consider the screening expenditure as in the static problem, and also the marketing expenditure that we make in each period. Now, the way we will formalize this problem is we will let the SI be a variable that reflects the state of the economy, which will include aggregated values of interesting macroeconomic variables such as the GDP or the unemployment of the country, which will give us an indication of how well the economy is doing. We will assume it evolves as a Markov model, where today's state of the economy is just a state plus some noise. Then, in order to assess the volume of borrowers that will be available during that time period, we will need to devise a model for the number of borrowers given the state of the economy during that period. So obviously, if the economy is doing well, then there will be more people in the market looking to carry out projects. And then also we will need to assess how many of those available borrowers are going to come to our bank instead of to the competition. And this depends on, first of all, how many of them there are in total, and second, the offers that we and the competition make, and the marketing effort that we and the competition make. So now in this case, we are again trying to maximize expected utility of the earnings we make from lending money. In this case, this has the earnings have three elements. The first one is the money we get from the projects when they are finalized. The second one is the money we lose by screening the projects, which we assume is constant for each borrower. And finally, the marketing expenditure. Now we'll see how this can be how this can be modeled in practice. So suppose we have one competitor, not two, and suppose we want to devise a lending strategy for the next 4 time periods. So, for example, for the next 4 quarters, we will assume for computational simplicity that the interest rates that we or our competition can make can be one of those 4 choices, and that the marketing expenditure that we or the competition can make can be only one of those 4 choices. We will assume, for example, that our organization is risk neutral. And then regarding the screening effort, we will make the assumption that we have, let's say, 2 states of screening. So the more expensive one, if we do it, will give us will result in a probability of 0.95 of accepting a project that will actually turn out to be successful. and if we choose the cheaper one, then the probability that we will accept a project that is successful is 0.9. And finally, we will assume that the screening expenditure per project is 1,000 euros. Now, regarding our competition, so we assume we have no idea of how much he will be expending on marketing. So we will assume an uninformative prior on his marketing expenditure. And then regarding his offers, we will assume that for the first period we'll give an equal probability to all the options, and then we will assume that a model for updating their offers, which basically acts by looking at what our bank has offered and trying to make an offer which remains competitive with us. So, for example, if in the first period our bank proposes an interest rate which is very low, then the competition will lower his offer in order to remain competitive with us. Now, regarding market evolution, we assume that the state of the economy is a numerical variable which follows this model. We will assume that the number of total borrowers in the market depends on the state of the economy through a Poisson model. Now, in practice, this would ideally be modeled through a Poisson regression using data from past years. In this case, we just assume this simple model. Then we have a model for the number of borrowers that will come to our bank rather than the competition out of all of those available in the market. And for this, we basically have a model where if we offer a lower interest rate than the competitor, then we tend to get more customers. And also, if we spend more on marketing, we have to get more customers. And this model is symmetric on both competitors. Now, we will assume that the projects that are presented by the borrowers have some success probability which is independent between the projects and which is higher when the economy is doing well and lower when it's doing bad. Now, we will assume for simplicity that both banks can only have the same requirements for the money that can be borrowed that is given between these two values. And we will assume that the applications that we get, the money that the borrowers ask for is uniformly distributed between these two values. And finally, we will make some modeling assumption about our beliefs about the return of the projects that are successful. That again, in a real data application would be modeled using past data, but in this case we assume just a simple normal model. And just to finish, this is the results that we get from this problem. So in each plot we have basically the accumulated expected earnings by periods. So we consider 4 periods. Each plot represents a different marketing expenditure. In blue, we have cases where we choose to the more expensive screening option, and in red, the less expensive screening option. And basically, what we get is that our optimal option is this one. It requires a screening, and it requires the small amount of marketing. Now, this was implemented using Monte Carlo, and we had to make various simplifications, such as discretizing the possible offers of us and our competitors. Now, to conclude, I will just mention that Roy and Simon are working on some way to extend this and to make to use random forest regression in order to be able to implement this kind of models with a continuous set of available interest rates. And that's it.
Thank you. Person or
Quick question. So how long those periods are? Is it like monthly or, let's say the reserve bank needs, I don't know, once every month to determine the interest rate and the banks will update their own decisions? So how often those periods are? You have for all, is it like once every week, once every month?
So we're considering yearly quarters.
Or
So yeah, in 1 year I have to make 4 decisions.
thank you.
any other comments? Okay, thank you. This is starting now, so we don't move for. That's right.